Today we're doing the last of our FRQ topics, Topic 10, Taylor Series. These are always no calculator, always number 6. Okay? Taylor Series, we need to know the format. Maclaurin is when C is 0. So a Taylor Series can be centered anywhere. Okay? Every term, derivative, factorial, power. Every term. Derivative, factorial, power. Every term. Okay? When it's centered at 0, it's called a Maclaurin series. Those are the easier kind. Okay? I will never forget the year that students came back after the test. When they came out, when the FRQs came out, they said, well, I was all prepared for a Taylor series, and it freaked me out because they gave me a Maclaurin series instead, and I just didn't know what to do with a Maclaurin series. And I just looked at them because they were making it easy for you. When C is 0, it's a little bit easier to manage. So anyway, whatever. Maclaurin is just a specific type of Taylor series when C is 0. We need to have memorized the Maclaurin series for sine x, cosine x, and e to the x. Recognize functions in this form. A sub n, it should be like terms in this form. Okay, that's the geosum form. So the series will look like that. Okay. So go back and review that if you need to. Okay. The coefficient of the 5th degree term is always the 5th derivative at C divided by the factorial. Okay. The derivative at C over the factorial. So if you're asked to find the value of the derivative, go to the term with x to the 6th in it and set its coefficient equal to this, and then solve for the derivative. Alrighty, remember that the coefficient includes the denominator. That sounds silly to have to say, but it is true, and some students just don't include the denominator in there. But it is part of the coefficient. Alright, use the ratio test to determine intervals of convergence. Show all work. Those are worth a lot of points. Okay. Alternating series error bound, Lagrange error bound, see the notes that we did for topic 9 on that. Okay? It went into far more detail in topic 9 there. Alrighty, be able to take the derivative or integral of a series term by term using the power rule. If you're asked to write a general term, you can always check it, plugging in a value of n to see if you get one of your terms. And don't be surprised, don't be rattled if they ask you to do something that is a little bit different. Okay, we are going to do the problem from 2024. Our KHS average was 4 on this one, and to be honest, that is fairly high for one of these types of problems. Usually these are lower. The global average was also a little bit high for one of these types of problems. Alright, the Maclaurin series, that just means that C is 0 for F is given by this and converges to F for all x in the interval of convergence. It can be shown that the Maclaurin series for F has a radius of convergence of 6. That makes me a little bit sad that they told us that, because if they hadn't told us that, we could have shown it and gotten at least 4 points. But they gave it to us, so oh well. Part A. Determine the Maclaurin series, whether the Maclaurin series for F converges or diverges at x equals 6. Give a reason for your answer. Okay, so the first thing I'm going to do is put in 6 for x. So we will have the series m plus 1 times 6 to the n divided by n squared times 6 to the n. Well, the 6 to the n's reduce out, and we're left with n plus 1 over n squared. Okay, now we're back where we were yesterday doing the convergence tests. How do we show whether that converges or diverges? Well, it behaves like the series for 1 over n. So it behaves like the harmonic series. So compare with the diverging, we need to say what it does, the diverging harmonic series 1 over n. And I'm going to use the ratio test, not the ratio test, the limit comparison test. So the limit as n goes to infinity, our given series divided by our known series. Dividing by a fraction is the same as multiplying by its reciprocal. We have n squared over n squared. The ones are irrelevant. Well, this one is irrelevant. So that limit is 1, which is finite and positive. So that series diverges. It does whatever the known series does. Okay? Part B. By the way, I guess I can do the points as we go. 1 point was for considers the series. They wrote it as, actually they didn't even say series, considers n plus 1 6 to the n over n squared 6 to the n. Did you consider that? And then 1 point was for the answer with reason. And I looked at the notes further on the notes for that. They required us to show the work for the test. They required us to show it to get that second point there. Part B. It can be shown that f of negative 3 is equal to this, and that the first 3 terms of the series sum to this. Show that when I see this, I think the error. Show that the absolute value of the error is less than 1 over 50. So this is an error question. When you see this, think, oh, this is error. Did they say Lagrange? No. Then they want alternating series error. Okay? And if they want alternating series error, we have to make that statement about the terms. Okay? So the terms are alternating in sign and decreasing in magnitude to 0. So the error bound is the absolute value of the first unused term. Okay? So they used the first 3 terms in the sum. We want the 4th term. Since we started at 1, the 4th term will be when n is 4. So I'm going to take this and put n is 4 in and make it the absolute value. Okay, so n is 4, so we'll have 4 plus 1 over 4 squared times negative 1/2 to the 4th power. We don't need that negative in there with the absolute value, and with the 4th power you don't need that negative in there. And then they tell us to show that that is less than 1 over 50, so we write less than 1 over 50. If you really wanted to, you could simplify this out and show that it's 1 over 50 that way. But they don't care, all right? At most, what could happen, or at worst what could happen if you tried to clean this up, is you could make an error adding, multiplying, dividing, squaring, whatever you need to do. This gives full credit. So 1 point was earned for uses the fourth term. Did you use the fourth term? Yes, we did. 1 point was for the verification, saying that it's less than 1 over 50. Another note here, we had to say, to get the verification, we had to say that the terms are alternating in sign and decreasing in magnitude to 0. Had to say that. Part C. Find the general term of the Maclaurin series for f prime, the derivative of f, and then find the radius of convergence of the Maclaurin series for f prime. So first of all, here is the series for f. That's f. To get f prime, we take the derivative of this with respect to x. With respect to x. So this mess, you guys, that's all just like a number. How do you use the power rule here for derivatives? Multiply n times the number and decrease the power by 1, right? So this mess is just a number. So f prime, the general term, I'm just going to write general term is, okay, n times the front, n times the front, right? Decrease the power by 1, so x to the n minus 1, over the n squared 6 to the n that was already there. Okay? That is the general term. So just take the derivative there. Now we're finding the radius of convergence for f prime. They gave us the radius of convergence for f. So the radius of convergence for f prime is the same. Remember that that's a theorem. The radius of convergence for f is the same as the radius of convergence of f prime and the radius of convergence for the integral of f. So those are all the same. So I need to say that. The radius of convergence for f is of the series for f is 6. So the radius of convergence, I can tell I've made too many videos, my writing is getting very sloppy, of the series for f prime is 6. No work necessary on that one. 1 point for the general term, 1 point for the radius of convergence. That means for part D, it's worth 3 points. Let's do part D. Part D, so let g of x now, we have a different series. Throw f out the window, and there's a new series in town. Use the ratio test to determine the radius of convergence. Radius of convergence problems are usually worth 3 points. Okay, interval of convergence are worth 4 points. Radius of convergence are worth 3. Of the Maclaurin series for G, so we're going to do that. I'm going to come down here. Oops, part D. All right, ratio test. So limit, remember it's a limit. N is going to infinity, absolute value. Take your a sub n, write the n plus 1 terms. So replace every n with n plus 1. Replace every n with n plus 1. So we'll have see if I can get this all up here. We'll have n plus 1, that'll be n plus 2, x to the 2 times n plus 1, divided by n plus 1 squared, 3 to the n plus 1. So that's the n plus 1 term, and we need to divide that by the nth term, which is the same as multiplying by the reciprocal of the nth term. So we're going to multiply that by n squared, 3 to the n, over n plus 1, x to the 2n. Okay, if you remember, back when we did this the first time, when you're taking this limit, so I wouldn't be writing this on my test, I wouldn't write this, but these, as n goes to infinity, so this is 3 to the first times 3 to the n. The 3 to the n's cancel, you're left with 3 to the first. So there's going to be a 3 on the bottom. When you take this limit, there will be a 3 on the bottom, right? But for the n's, n squared on top, what I see here is an n squared on the bottom. The plus 1, as n goes to infinity, that plus 1 will be irrelevant. Okay? So for the n's, the limit of that is 1. The limit of this, the n plus 2, n plus 1, that limit is 1. So remember, any polynomial term, when you take the limit, it'll be 1. Okay? But for our x's, this would be 2n plus 2, right? So which would be x to the 2n times x squared. The x to the 2n's will cancel. We'll be left with x squared. You can think of that as being absolute values. We don't actually have to have those absolute values since it's a squared, but I like to still think of it as being an absolute values. It helps me with what's about to come. Multiply both sides by 3. Take the square root of both sides. So the radius of convergence is the square root of 3. 3 points. 1 point for setting up the ratio test. 1 point for finding the limit, the correct limit. And 1 point for your answer, the radius of convergence. Taylor series. If you want extras, you can go to any year of the exam. It's always number 6 if you want to see extras.